when you supply heat energy, you know that the volume increases and the water starts becoming into vapor state at, okay. When you actually cool this water, what happens? So when you decrease the temperature, reduce the temperature, what do you think is happening to this one, molecules? They come very closer. So shall I draw like this? They come really close like this. Okay, is it correct? So when I reduce the temperature, you are saying it is going to move slowly. So when it moves slowly, I can say it is arranged very closely and the volume would decrease. Is that right? This is the correct picture? No. But when you reduce the temperature of water, what happens? It becomes like a what solid? What is it? Ice. So liquid becomes ice, but we know like in ice, in solids, usually in solids, how are atoms placed? They are tightly packed, and most important thing is fixed to its positions, correct? So this one is in the liquid state, correct? So what you are saying is, when I reduce the temperature in solids, that is in the ice, as ice is the structure of ice? No, this is not the structure of ice. So how does it look? So ice will be it will have a crystal like structure. Can you see the gap between these things? It will have a crystal like structure. So at one particular point, as you keep reducing the temperature, at one particular point, all these molecules, they start moving slow. I mean, as you reduce the temperature, they will start moving slowly, but at a particular temperature, they will get their positions in place and they get arranged like a crystal. This is called ice. Okay. So that is why we have ice as a solid. We have two conditions for solids, right? One is fixed to its position. Okay, correct? So we have that in place now. So at a particular point this happens. What is that point? 0 Celsius. Correct. At 0 degrees Celsius, what happens is water becomes ice. But ice means you have empty space and it is like a crystal structure. So when I put ice, okay, what happens is it floats, correct? Doesn't sink. But solids usually sink in water. Why does ice float on water? Less denser. Anything else? More volume. It has so much space in between that because of its arrangement, it is actually floating on the water. Okay, what do you think will happen if the ice is not floating on the water? Will it affect us? More important thing is like we will not have sea lives at all, right? Because so what happens in the winter, there will be a thin sheet of ice that is floating. Below that it is warm for the life to survive, right? So if everything is ice and it is sinking, all the water becomes like ice, what happens? The fishes and all will die. So it actually causes lot of impact if the ice is not floating. So ice floating is very important, okay. But why is ice floating? Because of the structure it is having and it has lot of space. That's one of the reason if you see it, if you fill the bottle to the brim, it becomes, I mean, always the ice will take that extra space, correct? So you need to actually keep it lower, right? Why? Because with this one, it is actually having lot of empty space, right? So it is going, the volume is bigger, it increases. So if you have this big ice cube, the water will be not equivalent to this, it will be lesser. So if you have till the brim and you keep it in the fridge, what happens in the water bottle and all, you have to fill it little bit low than the brim. So if you fill it till the brim, it will come out, I mean the water will come. Yeah. So it becomes very difficult. So what happens is, more than the water, so the water, if you have like so much of water, when it becomes ice, it takes some extra space. And why it is taking extra space? Because of its structure. Okay. At 0 degree, it start melting, right? The melting point and the freezing point are the same. So the freezing point of water, correct, is equal to the melting point of which is 0 degree Celsius. It's the same. But ice, will it be only in 0 degree Celsius? Minus 5, minus 15, minus 45, minus 150, minus 373, yes, minus 500, it will go up to, it will go up to minus 273 degrees Celsius. What you have to understand is, when you are increasing the energy level, when you are supplying heat energy, there is no limit. You can supply how much ever you want. Okay, when you decrease the temperature, so what happens when you reduce the temperature, the molecule starts moving slowly, right? So at this point, this is the 0 Kelvin or absolute zero. Okay. So till now they have come to only this point, that is minus 200. So when you are lowering the temperature, it can go only up to minus 273 degrees Celsius. So now let's do a small graph and try and understand what happens. I'm sure like you would have seen this graph. So from minus 273 degrees, and here it is 0 degrees Celsius, and from here this one would be water, 100 degrees Celsius, and then steam. So this part we call as latent heat of vaporization, and this part we call as latent heat of fusion, and this is nothing but temperature, and this is time, that is the heat energy supplied. So if we take ice at 273 degrees Celsius and if we actually supply heat energy to it, initially you will actually see there is an increase in the temperature. But at this particular point, that is at 0 degrees Celsius, what happens is suddenly the increase in the temperature stops, and then the graph is constant for some period of time. Again the temperature increases and it stops at 100 degrees Celsius, and then again it remains constant, and then it is converted into steam. So what is happening here? So though we are actually continuously supplying heat energy, the temperature is not raising at this part. Again the temperature is not raising at this part. So we should understand what is happening at this phase. So what is happening is, I have, let's take like in a beaker, I have lot of ice cubes and I start supplying heat energy to it. So what happens is, so now initially the ice cubes takes up the heat energy. So a few molecules break their bonds. So what happens is, when they actually break their bonds, they need lot of energy. So they take the heat energy for breaking the bond from the ice structure. So what happens is, like a few of the ice cubes actually melts and they become water. Now you have this much of water and this much of ice cubes. But we can think of this way, that when I supply heat energy now, initially everything was ice. Now I have ice as well as water. So now this water can actually increase, right? So if this can actually boil and the temperature can increase. But it is not happening that way. So what is happening is, though I am supplying lot of heat energy, the heat energy is being absorbed by other ice molecules in breaking up the structure. Instead of actually heating up this one, the heat is absorbed by the ice molecules. That's why you have here as a constant graph, because all the energy that has been supplied has been taken by the ice and they actually take the energy for breaking away from the structure. So they all become water. Once everything has become water, converted into water, so ice to water, at this point what happens is, now the energy that I am supplying, it will actually increase the temperature. Again, at a particular point, that is at 100 degrees Celsius, what happens is, again it is constant. That is because whatever energy I am supplying to the water, all the molecules should gain at a particular, in which they actually convert into steam. So when they are converting into steam, it means they are breaking the bond here and they are flying away. So all the energy that have been supplied is spent by the molecule in breaking the structure and flying away. So that's the reason we have this as a constant. So here it is converting from ice to water, here it is converting from water to steam. So now let's do this experiment to understand whether this actually happens. We know that we have been given this graph and we know it is given in the textbooks, but does this really happen? So let's try out this experiment and see. So right now this is at a room temperature, which we can see the reading has come to about 30 degrees. Okay, so now let's take this beaker which has lot of ice in it. You could see like already there is some water. So I put this thermometer inside this beaker which has lot of ice cubes. You could see that the reading has come to about 1 degrees. It's still reducing, and this one has up till -10. I don't think this is going to go till -10, but this will actually go to till I think 0 degrees Celsius. Already since the water started melting, now let's start heating it up and see whether the energy is actually used by the water or by the ice. Okay, so I'm going to heat up this one. So let's have this thermometer like this. Inside this one I'm going to heat the using candle. So now I'm supplying heat energy to the system, and this should not increase the temperature. Okay, so as I am supplying the heat energy, if this is increasing, then whatever we have learnt in the graph is not correct. But if we actually see that this is not increasing and it is constant, but the ice is getting converted into water, then what we have learnt is true. That's what now we are seeing here. So I am supplying heat energy to this one. Let's wait and see for like 2 more minutes. So now this is becoming hot, and you could see like more ice is getting converted into water, but the reading here has not changed much. Let's wait for 2 more minutes to see more water, less ice, and the constant reading at the thermometer. So now there is definitely an increase in the level of water, okay, but there is no increase in the readings. Okay, so now what I am going to do is, I am going to remove the ice cubes and heat the water, and see, you can actually see that the temperature is rising. Okay, so now let's remove the ice cubes and increase the readings in the thermometer. Now I have actually removed all the ice cubes and I am placing the thermometer here. So now you could see that there is a increase suddenly, like from 0.2 it is going to 5, 6, and it keeps on increasing. Till what degree it will increase? Till 100 degrees Celsius. Afterwards again it will remain constant. So after that, whatever heat energy I supply, all of it are used by the molecules to break away the bond and get converted into steam. So now it is actually increasing. You could see that it has come to a point where 20. So it keeps on increasing. So if I leave it for another 5 to 10 minutes, it will reach a point of 100 degree Celsius. Now after like 5-10 minutes, you could see like it is reaching 60 and it's still getting heated up. So 65, it is coming, it's still raising. Okay. So now we could see that it has reached about 80 degrees Celsius and it's keep on rising. So if we wait for another 15 minutes, it will actually reach 100 degrees Celsius, and then you will start seeing there is no more increase in the temperature. So you could actually try this experiment at home, but don't burn your hands and all. Be careful, have an adult supervision and try this at home to see that it is not going beyond 100 degree Celsius.